Welcome back to lesson 11, where we're going to continue exploring fraction, decimal and percentage relationships. Make sure you've got your work from yesterday because I'd like to go through the solutions for those and have some pen and paper ready for today's lesson. See you in a moment. Miss Chambers left you this practice question. Let's read it together. It says that a zoo has 300 butterflies in its butterfly house. 1% of them are rare banded peacock butterflies, and how many banded peacock butterflies does the zoo have? So there's some information in there that we can isolate straight away, isn't there? Some key information. First of all, we have to start thinking, don't we? What would 100% be? I know we've been using ratio tables, and when we write a ratio table, very often we're able to identify 100% in that first, aren't we? What would be 100% in relation to this problem? 100% is 300 butterflies. Excellent. So that's the total amount of the butterflies. So if 100% is equivalent to 300 butterflies, it says 1% of them are the rare banded peacock butterflies. What do we know is the relationship between 1% and 100%? Yes, that's right. We know that 1% is 1/100th of 100%. So it's 0.01, isn't it? 1/100th, 1%. So how do I find 1% of 300 if my whole amount is 300? What operation do I use? To find 1/100th, I divide by 100. Fantastic. So 300 divided by 100 would be 3. Excellent. So there are 3 banded peacock butterflies. Let's have a look at the challenge question. Class 6 are doing a sponsored silence for the whole of the 6-hour school day. So far they are 10% of the way through. How long is left? I don't know about you, but I've never known a year 6 class that can stay silent for 6 hours. However, they're only 10% of the way through now. What relationship is 10% to 100%? Yes, it's a tenth, isn't it? Now, do we know what 100% is in this problem? Can you underline with your finger where it tells me what the whole is in this problem? Ah, yes, it says the whole of the 6-hour school day. So 6 hours is 100%. Fantastic. And they're 10% of the way through. Do you think we'll be expressing our answer in hours or minutes? I think we're probably better expressing it in minutes, aren't we? Because 10% of 6 hours is probably going to be in minutes and not in full hours. So should we convert 6 hours into minutes? That would be easy, wouldn't it? So we know there's 60 minutes in an hour. So 60 minutes is 360 minutes. Fantastic. So did you do a ratio table where you showed that 100% was 360 minutes? And we've just said, haven't we, that 10% is the same as 0.1, which is a tenth. And so to find a tenth, we divide by 10. So if we divide 360 by 10, we have 36 minutes. Fantastic. Oh, I don't know why that was a challenge. Have we finished? I'm going to reread it. Seemed too easy. So far, they are 10% of the way through. How long is left? I nearly missed that. I was going to leave my answer as 36 minutes. Would I have been right? No. What do I need to do? So they want to stay silent for 360 minutes. So far, they've done 36 minutes. How long is left? I'm going to have to subtract. Fantastic. So did you say 360 minutes, subtract 36 minutes is 324 minutes. It's really well done if you did that. And perhaps some of you put your answer as 36 minutes, and that's why it's really helpful, isn't it? We look back at the question and make sure we've completed all parts of it. Well done. Do you remember in the last lesson you were looking at this bike ride, weren't you? And we said that they had completed 50% of the bike ride. And how did you work out what 50% of the bike ride was? Yes, that's right. You knew that 100% was 420 kilometres. So how do I find 50%? I divide by 2. Why do I divide by 2? Because 50% is equivalent to a half. Excellent, well done. And if I divide 420 by 2, I get 210, don't I? So to find 50% of the number, we divide by 2. Can we repeat that together? To find 50% of the number, we divide by 2. And we know that that's because 50% is equivalent to a half. What would that be as a decimal? It would be 0.5, wouldn't it? And so what does that mean in hundredths? That would be 50 hundredths. Excellent. So we can see how they all link, don't we? 50 hundredths is the same as a half, which is the same as 50%. So we can use all of that knowledge to very quickly divide by 2. Have a little look at this number line now though. So this number line shows the original 50% of the journey that had been travelled, but now there's another bike on there and a blue line that shows 25% of the journey. So how would you work out the distance Zara has cycled if she's 25% of the way through her bike ride? I'd like you to pause me now and have a think how you might work that out. How did you get on? What kind of things were you thinking about? Were you thinking about the relationships between fractions, decimals and percentages? I know I mentioned on the last slide, didn't I, that 50% is the same as 50 hundredths. So how many hundredths would 25% be? It would be 25 hundredths, wouldn't it? Do we know a fraction that 25 hundredths is equivalent to? We do, don't we? Because we did loads of work on that in previous lessons. So 25 hundredths is equivalent to 1/4. Fantastic. So 25% is equivalent to 1/4 because it's the same as 0.25, which is 25 hundredths. Excellent. So now we've looked at that and we've thought about our decimal relationships, fraction decimal relationships. Can we use that to help us solve the problem? So I asked you, how do we know what 25% is? Did anybody do this method? Did you say that 25% is half of 50%? It's true, isn't it? We can see that, can't we, on the number line? We can see that 25% is halfway in relation to 50%. So what would that value be? It would be 105. Fantastic, because a half of 210 is 105. Good. Well done if you used method 1. Did anybody do it differently? So we can see that. Can we see anything else? Did anyone perhaps say that 25% is equivalent to 1/4? So we mentioned that, didn't we, at the start when we were thinking about what these values mean? Okay, so if 25% is equivalent to 1/4, how does it help me to find the value of 25% of the journey? What did I do when I found a half? I divided by 2, didn't I? What do I have to do to find a 1/4? I will divide by 4. Fantastic. So I can see here, can't I? If I look at my number line, I've got 1, 2, 3, 4 equal parts. So the whole of the journey, which is 420 kilometres, has been divided into 4 equal parts, and I'm looking for one of those parts, aren't I? So 420 divided by 4, is that 105? Yes, it is, isn't it? So 2 really good ways that we could find 25% there. Perhaps you found them both, or perhaps you found one more efficient than another. It's really good practice, once we've been using our mental strategies and finding these values, to jot them in a ratio table quickly, because we might need them in a problem-solving context. So as we said, the whole journey was 420 kilometres, so we knew that was 100%, and so that's a known percentage for us. And then we could very quickly find 50% because we knew that we could halve it, we could divide by 2, because 50% is 50 hundredths, which is 0.5, which is equivalent to a half. And then we said that we could find 25%. Let's have a think about how we would read this. So we're saying that 50% of 420 kilometres equals 210 kilometres. Let's do the same with 25%. So we found out that 25% was 105 kilometres, didn't we? Because we said it was either 1/4 of 100%, so 420 divided by 4, or we could halve 50%. And actually, when you think about it, if we divide by 4, we actually do half and half again, don't we? So we find half, and then we found half again, which was 105. So that's a really good mental strategy too. How would I read this? I would say that, read it with me, 25% of 420 kilometres is equivalent to 105 kilometres. Brilliant. Excellent. Do you think you can use the information we have in our ratio table to find 75%? And that's why it's really good to record our mental strategies in these ratio tables, because they can help us to find other unknown percentages. So I'd like you to try and work out how far Zara would have cycled after completing 75% of the journey. Do you think you could have a see if there's a couple of different methods to that, or if there's perhaps a method you find easier than a different one. Have a go at that. Pause me now. Okay, how did you get on? Quite a lot to think about there. So we had our ratio tables, didn't we? And we can see on the double number line that we've got our known values. So we know that 100% is 420, we know that 50% is 210, and we know that 25% is 105 kilometres. 0%, let's not forget 0%, that would be no kilometres at all, wouldn't it? Because we've not started our journey. Excellent. So there might have been a few different ways that you tried to find 75%. I wonder if anyone tried to do this. Did anyone try to combine 50% and 25%? What does that mean? Yes, that's right. If I know that 50%, the journey from here to here is 210, where is 75% on my number line? Where is it? 75% is 75 hundredths. Fantastic. And 75 hundredths is the same as 3/4. Brilliant. So we know we've got 1/4, 2/4, 3/4 and 4/4 makes our whole 100% of the journey. Brilliant. So we know that. That's another known fact to us, isn't it? The 75% is 0.75 and that's 75 hundredths, which is equivalent to 3/4 and 75%. So we know all of these facts at our fingertips. So if I combine 50% and then I add another 25%, because I know that 1/4 is equivalent to 105, then I should be able to find 75%, shouldn't I? Did you have a go at it that way? So we can see, can't we, that 75% of 420 is 210 plus a further 105, which makes 315 kilometres. Brilliant! Did anybody do it differently? I'm wondering if anyone looked at it differently, because that's one way of doing it. Perhaps some of you said, well, I can find 3 lots of 25% because it's 3/4, and that's what it means. If 1/4 is 105 kilometres, then 2/4 is a half and would be 210 kilometres, and 3/4 would be 315 kilometres because it's 3 lots of 105 kilometres. Brilliant. So a couple of different ways we could find it there. Just wondering, I think some of you might have done it slightly differently. Did anybody do this? Did anybody subtract 25% from 100%? Why might I do that? Ah, brilliant. Yes, because we know that 100% is 420 and 75% is 25% less, isn't it? So he needs to cycle another 25% to do the full journey. So we can decrease by 25%, can't we? So 75% of 420 is also equivalent to 420 subtract 105, which is the value of 1/4. And we get the same amount, don't we? So lots of different ways there. But actually, when we think about it, we found the unknown percentage by using our known facts, didn't we? We looked at the percentages we did know and combined them to find the ones we didn't. And we complete our ratio table again now. So 50% is 210 kilometres, 50% of 420 is 210 kilometres, 25%, which is 1/4, 25 hundredths, 0.25, 25% of 420 kilometres equals 105 kilometres, and we said that 75%, which is 75 hundredths, which is the same as 3/4, we've managed to work that out using several different methods as 315 kilometres. And do you think you can read with me how we would say that? We would say 75% of 420 kilometres equals 315 kilometres. So our ratio table came in really handy, didn't it? Because when I had found 50% and 25%, I could use those facts to help me find an unknown quantity of 75%. So it was really useful. Do you remember when Rishi did the same journey? He only managed to do 10% of it though, didn't he? What's the relationship between 10% and 100%? Yes, that's right. So we know 100% is the whole journey And 10% would be 1/10 of that journey, because we can see, can't we, that the whole journey has been divided into 10 equal parts. So 10% is 1/10, which is 0.1. And what does the one digit mean in 0.1? It means 1/10. But how many hundredths is that? Can you remember? It's 10 hundredths, isn't it? So actually 10% is equivalent to 10 hundredths, which is equivalent to 1/10. And we know how to find a tenth, don't we? We can divide by 10. Fantastic. And we know how to divide by 10 really easily because we use our knowledge of place value. So 1/10, 10% of 420 is 42 kilometres. Excellent. Now you might notice that I've put some extra values in this ratio table just for you to have a think about. So let's have a look at 5% first. So I've said that 5% is 21 kilometres. Am I right? Pause me now and have a think about whether that value is right, and if so, why? Or why not? What did you think? Is 5% 21 kilometres? Yes, it is. How did you know? Where would 5% be on my number line? 5% would be, it'd be here, wouldn't it? Because 5% is 5 hundredths. Excellent. It's not 50 hundredths, is it? Where would 50 hundredths be? 50 hundredths would be here. That's a half, isn't it? And this is 10 hundredths. So 5 hundredths would be here, wouldn't it? 5 hundredths, 5%. And actually we can see, can't we, that is halfway, isn't it? 0, 5, 10. So it's halfway between 0 and 10%. So it's half of 42, which would be 21. Okay, can you have a look at 20% then? Tell me if you think 20% is correct. Is that the right value for 20%? And if so, why? And if you don't think it is, why not? Pause me and have a look at that. What did you think? Where would 20% be on my number line? Put your finger where 20% is. It's here, isn't it? Fantastic. So if that's 20%, how could I calculate it from the known facts that I already have in my ratio table? Excellent. So I know that 10% is 42 kilometres. So I've got another 10%. So it's 42 plus 42. 10% plus 10%. 10 hundredths plus 10 hundredths is the same as 20 hundredths. It all works out. So 20 hundredths, which is the same as 2/10, isn't it? Which is also the same as a fifth. So perhaps we could have done that, couldn't we? We could have said 420 divided by 5, and that would be 84 as well. But is that as easy a calculation? I don't think it is it? So I think that you would probably all have said, oh, it's just double 10%. So 20% of 420 kilometres is 84 kilometres. And you would have been perfectly right. So how do you think we could find all the other multiples of 10? How did we find this multiple of 10? We multiplied 10% by 2. Excellent. How do you think we would find the other multiples of 10? Could we perhaps multiply 10% by each of those? Yes, well done. So if I've got 30%, I could do 3 lots of 42, or 4 lots of 42, or 5 lots of 42. So that's one way of finding all the 10%, isn't it, along the number line. So again, we've been saying the whole point of a ratio table, I've got my known amounts, my known percentages, then I can find unknown percentages from those. Do you think that's particularly efficient though, listing all of those and going through like that? Would you know what 742s were off the top of your head? Would that be really easy? Or perhaps there'd be something else that would be easier to do. Let's have a look out over here. Are there any of these percentages that you might just know straight away? I'll be able to derive straight away. Yes, perhaps we could find 50% straight away, couldn't we? Because we know that 50% is halfway. So one whole of the journey, the whole 420 kilometre journey, can be divided by 2. So if I divide that by 2, I get 210 kilometres. Well done. So I can find 50%. So if I know what 50% is, so I've got 10%, 5%, 20% and 50% as my known percentages here, and ones that I can derive really quickly, Might there be an easier way to find 30% than multiplying 10% by 3? I could multiply 10% by 3, couldn't I? But is there perhaps a different way of doing it? Pause me now and have a look. What did you think? Ah, that's a good idea. So did some of you add 20% and 10%? What a good idea. Because if I've got 20% and I add another 10%, then I've got 30%, haven't I? So 84 plus 42, that's quite an easy calculation, isn't it? So I get 126. Really well done. Was there another way of doing that? I could have said, oh, I could have done 6 lots of 5%, couldn't I? Because I know that 5 6s are 30. So I could have said 6 times 21. That would be another way of doing it. But actually combining 20% and 10%, because I've already got them listed, was probably the most efficient. What about 40%? How could I use the known facts in my table to help find 40%? I can hear you, you're saying double 20%, because if I've got 20% here and I double it, so I add another 20%, that's where 40% is. Oh, it's just under 50%, isn't it? But if I double 20%, is that easy to double? Double 80, 160, double 4, 8. That's nice and easy, isn't it? So another way I could do it, I just noticed there that 40% is very close to 50%, so I could perhaps do 50% subtract 10%. Let's see. So I know that 50% is 210, and I'm going to subtract 42. Is that as easy as doubling 84? I don't think it is it? I could use it if I wanted to, but I think doubling 84 is an easier mental strategy, so I'm going to stick with that one to find that unknown percentage. So far we've been combining percentages, haven't we? So we've combined 2 20% to make 40%. We've combined a 30 and a 20 to make a 50. We've also found half of 100 to make a 50. And we're really flexible again, aren't we, in the different ways we can find these. How would you find 90%? Would you combine percentages again? Or perhaps you might think there's a more efficient way. Have a little look, see what you think. How did you get on? Did people think that maybe we could combine 40 and 50? Because that would make 90%, wouldn't it? 50, 60, 70, 80, 90%. We could do that, couldn't we? I've got 210 added to 168. I can do that mentally quite easily. How else? What else do I notice about 90%? I notice it's very close to 100%, don't I? So it's 10% less. I've decreased 100% by 10%. Excellent. So is that an easy calculation? Do I know what 100% is? Yes. Do I know what 10% is? Yes. So I could subtract 42 from 420, couldn't I? And would I still get the same as if I had combined 50 and 40%? I would, wouldn't I? I get 378. It's really interesting, isn't it? All the different ways that I can find these unknown percentages. There isn't just one way of doing it, is there? Would subtracting 10% off 100% be easier than doing 9 42s? I think it would, wouldn't it? So actually, although we can see that that's a very standard way of finding each of the multiples of 10, there are other ways we can do it that might be a bit quicker and a bit more efficient. Right, quickly look at 80%. How did you get on? Did some of you do 100% subtract 20% and then you found it was 336? Some of you might have done 50 added to 30 because 50, 60, 70, 80%. So many different ways we could do it. Excellent, well done. And 60%, what do you think is the most efficient way that way? That's right, I think I would do 50% added to 10%. That seems the easiest, doesn't it? Because I've got those and they're my standard ones that I always tend to put in my ratio table. So I would get 252. And that just leaves 70% to find. Find it any way you like. Find 70% any way you like. How have you found it? Did you do 50% and 20%? Excellent. And if you did, you would have got 294. But some of you might have done 100% subtract 30%, and that would get you the same value. So really, what we can see from this is that actually we write our ratio tables to find key facts, to find those fraction, decimal, percentage relationships that we know really well. So we know 50% really well, don't we? We know how to find 10% really well. We can find 25% really well. And once we've got some key facts in our ratio table, we can use them to find any other percentage. Throughout this session, we'll be looking at how we can use our knowledge of fraction, decimal and percentage relationships to find unknown percentages from those that we do know. So for example, if we know 50%, we also know that we found half. We know that 50% is 50 hundredths. We know that it's 5 tenths. And so we've got all of that knowledge, haven't we? Those are our key facts that we know off by heart. And if we know those and we can find those percentages from 100%, then we can also find unknown percentages using those facts. So let's say this generalisation together. We can find an unknown percentage by adding together or subtracting from known percentages. So like in the last example, if we wanted to find 90% of the whole amount, we could subtract 10% if we know what 100% is. So it's really, really useful. But actually, I'd like you to have a go now at finding these values yourself in a ratio table. Do you think you're ready to have a go? I think you are. So we want to find 40% of 15. So we know 100% is 15 because the whole amount is 15. And actually, there's several different ways we know now that we could find 10% or 40%. We use the ratio table to find those values. How did you get on? How do we find 10% of a number? 10% is how many hundredths? 10 hundredths. What's that as tenths? 10% is 1/10. So if we're finding 1/10 of 15, we divide by 10. Brilliant. So 15 divided by 10 is 1.5. Well done. So if I know 10%, how do I find 40%? I can multiply it by 4. Fantastic. And we saw that in the previous slide, didn't we? So 1.5 multiplied by 4. Should we do it together? I kind of like there. If I'm times it by 4, I know I'm doubling again. So 1.5 doubled is 3. And 3 doubled is 6. Brilliant. And I don't have to put 6.0, do I? Because that would be a redundant 0. I only need my ones digit. Cool. Do you fancy doing another one? Have a look at this one. Pause me now and see if you can find the missing values here to help you find 75% of 240. How did you get on? So we know that 100% is 240 and we want to find 75%, which is 3/4. Why do you think it's finding 50% and 25% first? Yes, because if we combine 50% and 25%, that is 75%, isn't it? We saw that on the double number line. So 50% is equivalent to 50 hundredths, which is the same as 1/2, which is the same as 5 tenths. 5 tenths is equivalent to 1/2. Brilliant. And that's 0.5. So 1/2 of 240 is 120. Gosh, we know so much information. Now, how can I find 25%? I can halve 50%, can't I? 25% is half of 50%. So half of 120 is 60. There was a different way we could find 25%, wasn't there? Did anyone do it differently? Did you say 25% is the same as 25 hundredths, which is the same as 1/4? And so 240 divided by 4 is 60. Is that right? So 4 lots of 60, is that 240? It is, isn't it? I can use the inverse to help me check it. Cool. Ratio tables are really helpful, aren't they? Because if I can find those key facts like 50% and 25%, I can use them to find this more difficult 75%. So I can say 120 plus 60 is 180. Bullseye. Fantastic. We've been using our ratio tables and our double number lines, haven't we, to help us find percentages of amounts. And this question is asking us to find 45% of 64. So we know 100% is 64. Where would that be on my number line? Yes, it'd be over here, wouldn't it? So 100% is 64. Now, I've already put the values in the ratio table. I want you to tell me if they're correct. Is 50% of 64 32? Yes, it is. Put your finger where 50% is. It would be there, wouldn't it? 50%, and that's halfway. So I divide by 2, 50 hundredths, 32 is a half of 64. Brilliant. So I've put that in the ratio table. Where's 10%? Put your finger where 10% would be. Did you put it there? Fantastic. So that's 10%, 10 hundredths or a tenth. So if I'm finding 1/10 of the whole, which is 64, it's 64 divided by 10, which would be 6.4. So that one's correct as well. And have a look at 5%. Is that one correct? Pause me and have a look and tell me why it is. Yes, what did you find? So 5%, put your finger where 5% would be. 5% would be here, wouldn't it? Because it's 5 hundredths. It's not 50 hundredths, is it? It's 5 hundredths, 0.05. 5 hundredths, so 5%, and it's half of 10%. And is 3.2 half of 6.4? It is. Brilliant. So this was the ratio table that I knocked up to help me find 45% of 64. How do you think it can help me find 45%? Because I've got 50%, I've got 10%, and I've got 5%. Do you think I can use those values to help me find 45%? Pause me now and see how you get on. What did you do? I bet you found that quite easy now, really, didn't you? Because if we know that 50% is 32, and we know that 10% is 6.4, and 5%, which would be here, is 3.2, can I use these values to find 45%? Where would 45% be on my number line? Can you show me where it is on the number line? It would be around here, wouldn't it? It's very close to 50. So perhaps some of you use this method. What's this method done? 45% of 64 equals 32 subtract 3.2. Can you tell me what they've done here? Brilliant. So they've done 50% subtract 5%. And is that where 45% will be? Yes, it is, isn't it? 50%, decrease it by 5%. So it's 28.8. Really well done. Well done if some of you did it that way. Did anybody do it differently? So we subtracted from there, didn't we? And we said we can use an efficient strategy, adding together or subtracting from. So we subtracted from 50%. Is there another way we could do it? We could perhaps, did anybody do this? So they've said 4 lots of 6.4. What's 6.4? 6.4 is 10%. So why would we need 4 lots of those? To make 40%. Let's have a look at that. 6.4, 10%, 20%, 30%, 40% would get us to here. Yes, that's right. And then what do we need to add? Another 5%. So this is correct as well, isn't it? Which do you find the easiest, method 1 or method 2? They both give us the same solution, don't they? We've got the same value. I think I find this subtracting from method easier because I can find 50%. I can find half of an amount really easily. And to subtract 5% was just one step, wasn't it? Here I've got to do some multiplication and some addition. And I've got decimals, so that could get very tricky if I'm trying to do that mentally. So I think I would have done method 1, but it's okay if you prefer method 2. That's what our ratio tables are for. So we can find those key known percentages using our knowledge of fractions, decimals and percentages, and then subtract from them or add to them to help us find unknown amounts. What about 69% of 800? So where would 100% be? 100% will be there, Miss Heaton. 100% is 800. Where would 50% be? Show me with your finger. Yes, it would be there, wouldn't it? And we know that that would be half of 800, which is 400. So I've already put these values in the ratio table for you, and I'm going to ask you to use them to find 69%. Let's check they're right though. So 10% of 800, so that's 1/10 of 800, isn't it? 10 hundredths. So 1/10 of 800, I divide by 10, so that would be 80. Fantastic. Do you agree it would go here? 10%, 10, 20, 30, 40, 50%. Yes, that's right, isn't it? So where would 20% go? 20% would go here. Fantastic. Oh, 20%. So that's 20 hundredths. How could I find that really easily from a ratio table? Yeah, relationship here. I've doubled it, haven't I? So 80 times 2 is 160. 80 plus 80 is 160. Really well done. So that's right. There's another way you could have found that though, isn't there? Because 20 hundredths is the same as 2 tenths, which is the same as 1/5. And 1/5, that's why it's 0.2, isn't it? Because it's 1 divided into 5 equal parts. So I could divide by 5, couldn't I, as well? So 800 divided by 5 is 160. Is that a particularly easy calculation? I don't think it is either. I'd much rather double it. It's way easier. So yeah, let's double 10% to get 20%. But we must remember in some situations that finding 20% is finding a fifth, and dividing by 5 might be easiest. Depends on the numbers, doesn't it? And then 1%, where would that be? Put your finger where 1% is. It will be here, yes, 1/100th. It's not 10 hundredths, is it? It's 1/100th. 0.01, 1%, 1/100th. Cool. So to find 1/100th, I divide by 100. 800 divided by 100 is 8. Excellent. So now I've got my ratio table. I'm happy with my ratio table. Can I use it to find 69%? So that's your job. Look at the different ways you can find 69% using those ratios in the table. How did you get on? There's loads of different strategies, aren't there? So I can add together or I can subtract from, can't I? Let's look at some of the different methods you might have used. So here's method 1. 69% of 800 equals 400 plus 160 subtract 8. So what have they done there? So 400 is 50%. We found that one dead easy, didn't we? And 160 is 20%. So why have they done that? So 50% plus 20% is, 70%. Right, because we need to look at where 69% is, don't we? Is it 70% there? 50, 60, 70, 80, 90, 100%. So 69% is just before 70%, isn't it? It's one less. We've decreased 70% by 1/100th. Gosh, we're so knowledgeable with our hundredths. So if we're removing 1%, if we're decreasing by 1%, we need to subtract 8. So that was good. Was that adding together or subtracting from method? It was subtracting from, wasn't it? We have subtracted from 70%. And we added together as well, because we combined 50% and 20% first and then subtracted from it. Wow. Do you think there's another method? Well done if you did it that way. What about this method? Have a look at that. What have they done? 69% of 800 is 7 lots of 80 and then subtract 8. 7 lots. Did you spot that? So it's 10%, isn't it? So it would be 70%. So we're doing 80 plus 80 plus 80 plus 80 plus 80. Excellent. So we're doing 7 lots of 80% because 10% is 80%. And then subtracting that 1% again. So that's a really good method as well. And actually, I should know what 7 eighths are, shouldn't I? And then use my place value knowledge to make it 10 times the size. So that one's quite an efficient method. And some of you might have done it slightly differently. Did anybody do this? Did anyone say that I could do 69 times 8? What have I done there? That's right, 8 is 1%. So I could have 69 1%, because actually 1/100th, I want 69 hundredths, don't I? So if I multiply 1/100th by 69, I will have 69 hundredths. So I could do it that way as well. And that I'm really just adding together, aren't I? I'm adding together 69 eighths, but I'm using multiplication because that is a faster process than adding all of those eighths individually. Excellent. We've done loads of really hard work, but just remember that actually to find those unknown amounts, those unknown percentages, we can find our key percentages within our ratio table and either combine them or subtract from them to find the unknown value, which in this case was 69%. Well, we've done an awful lot of work there, but perhaps we could relate it all to this real life problem that you started this unit with back in an earlier lesson. And you had this pie chart to show how year 6 travelled to school, didn't you? And there were 120 children in year 6. So what is 100%? If I had a ratio table, 100% would be 120 children. Really well done. So that's the full amount of children. and it showed the different ways that they walked to school, bicycled, went by car or by bus. Actually, if we want to find 45%, we now know we could, what could we find instead? We could find 50% and subtract 5%. How would we find 30%? We could find 3 lots of 10%. So we can look at the problem, can't we, and think, what knowledge do I need in my ratio table? So 50% is going to help me. So let's find 50%. So I know that's just a half. I'm dividing by 2, so it's 60. Easy peasy. And it might be helpful if I find 10%, because 10% is really useful, because I've got multiples of 10% over here, haven't I? So finding 10% would be good. So that's 10 hundredths, which is 1/10 of 120. So I divide by 10, so that would be 12. Would it be useful to find anything else? Perhaps I could find 5%, and I can find 5% by halving 10%. And that's dead easy, isn't it? Half of 12 is 6. It's a doddle, isn't it, when we use ratio tables to solve these really complex looking problems? Do you think it might help me to find 1%? I'm not sure if it will, because I've found 5% now, haven't I? By halving 10%, so I'm not sure I need to find 1%, but let's have a look and see if it helps us. So 1% would be 1/100th of 120, so 120 divided by 100 is 1.2. Cool. Well, I think we have all the information we need to solve this problem now. So 30% would be 3 lots of 10%, so we've got 36. 20% would be double 10%, so we got 24. 45%, what's the most efficient method there? I think if we find 50% and subtract 5%, yeah. So 60 subtract 6, 54, easy peasy. And actually we got 5% in our ratio table, haven't we? Because it was half of 10. So we didn't end up needing 1%, but sometimes it's useful to have 1% in. Perhaps one of these might have said 49%. And then I'd have needed my 1%, wouldn't I, to subtract 1%. So make sure when you're writing your ratio table, you put the amounts in there that are going to help you to solve the problem. Really well done. If you're still with me towards the end of this lesson, we've done an awful lot of learning. But what I really want you to think about is that we know that we can find unknown percentages if we have known percentages that we can find using our key facts. So knowing that we can find 50% by halving the full amount, and finding 10% by dividing by 10, and finding 25% by finding a quarter. If we're really secure at doing that, and we can put those in a ratio table, then we can find any amount of the whole that we want to. So I'd like you to find these percentages amounts, but remember, write a ratio table or a double number line to help you. Perhaps you might have time for a challenge. So it's another pie chart, and it's showing what 60 Year 6 children voted for at their end of year treat, so what they wanted to do, and they could go to the cinema, climbing, bowling, adventure playground, etc. So these are the different events they wanted to do. And so do you think you could draw a ratio chart to help you find those unknown amounts? You'll need to identify what 100% is. 100% is mentioned in the question. And then when you've found those percentage amounts, do you think you could put them on that bar chart that shows you the number of children who've done each activity? So really well done if you managed to get a chance to do the challenge, and I look forward to seeing you again. Bye.